5.3, we're going to look at functions and what they look like on a graph, and we're going to graph them using a table. So you need to make sure for the graphs we're going to do that you have a ruler or straight edge accessible, and you're going to want a calculator ready to go. So a function rule is an equation showing how the variables are related. So again, remember we've talked about this in 5.2 that your functions can be set to y equals, or it could be f of x equals, or g of x equals, or h of x, but this still is the same idea as a y. So when we are graphing, f of x is going to represent our y values. So what we're going to do is we're going to use a table to graph. In a table, you're going to have your input values on the left, which we always input into x. You're going to have your function rule in the middle because we're going to input in there. And then your output values will be your y, or this could also be f of x or g of x, etc. Okay? The domain values, or our input values that we're going to input, are going to be the following. So we're going to get in the habit of always inputting -2, -1, 0, 1, and 2. Okay, so we're going to do this first example. So our function is f of x is equal to 3x plus 4. So we're going to make our table. We're going to make 3 columns here. Our first column is our input, which is x. The middle column is going to be our function, f of x equals 3x plus 4. And then our last column is our output, which is f of x. Remember, that's the same thing as y. I'm just going to put that in parentheses. So when you're graphing, you know that those represent your y coordinates. And then we're going to plug in the following numbers, -2, -1, 0, 1, and 2. And this is where you're going to have your calculators handy. So the first thing we're going to do is plug in -2. So I'm going to rewrite my function. And instead of x, I'm plugging in the number in parentheses. So don't forget that. And you could just do this on your calculator, 3 parentheses -2 parentheses plus 4. And when you do that, you're going to get out -2. Now I'm going to plug in -1. So I'm going to do the same thing, 3. Instead of -2, now I'm plugging in -1. So 3 times -1 is -3, plus 4 is +1. Now I'm going to plug in 0. So 3 parentheses 0 plus 4. 3 times 0 is 0, plus 4 is 4. Now I'm going to plug in +1. 3 parentheses 1 plus 4. 3 times 1 is 3, plus 4 is 7. And then lastly, plug in +2. 3 times +2 plus 4. 3 times 2 is 6, plus 4 is 10. So now, if you'll notice, I have an x value and a y value that goes with it. And when we have an x and a y, that represents a coordinate or an ordered pair. So the first point that I'm going to graph is this point -2, -2. Then the second point I'm going to graph, this x with this y, -1, 1. Third point, 0, 4. Fourth point, 1, 7. Fifth point, 2, 10. And so we're going to graph those points. And remember, when you're graphing, your x-axis is the one that's horizontal, that's left and right. Your y-axis is going to be vertical, up and down. So the point -2, -2, I'm going to go left 2, down 2, put a point. -1, 1, left 1, up 1. 0, 4, I don't go anywhere on the x, and I go up 4. 1, 7, right 1, up 7. 2, 10, right 2, up 10. And then you're going to take your ruler and you're going to connect those points. And notice that this function represents a line. So this function right here is going to give us a line. When you just have an x by itself, you don't have any exponents, and you don't have any absolute values, nothing else. Okay? Next example, now we're going to look at what happens when our function, notice, has absolute value bars. So these absolute value bars are going to change things. You're going to set up your table the same way. Your input is your first column, which is your x. Put your function in the middle, absolute value of x plus 3. And then your output is your y. In this case, they set it equal to y, so we can put a y there. And we're going to plug in the same numbers again, -2, -1, 0, 1, and 2. And then we're going to plug in. So we're going to plug in the absolute value, and then we're plugging in -2 here. Absolute value of -2 plus 3. And remember, when you do the absolute value of something, it's always positive because absolute value represents distance from 0. So this is like saying, what is -2's distance from 0? Well, it sits 2 units away from 0. So 2 plus 3 would be 5. Now we're going to plug in -1 into the absolute value. -1 into that absolute value. So the absolute value of -1, remember, everything pops out positive. So it's distance. So 1 plus 3 is 4. Now we're going to plug in 0 into this absolute value. The absolute value of 0 is 0. 0 plus 3 is 3. Now we're going to plug in 1, positive 1 into the absolute value. Again, everything still pops out positive. It doesn't matter that it's a positive inside that absolute value. The distance that 1 sits from 0 is positive 1. So 1 plus 3 is 4. And then the last one, we're going to plug in positive 2 into the absolute value. Again, positive 2, the absolute value is positive 2, and 2 plus 3 is 5. And so what you should notice when we have absolute value, since absolute value is always positive, notice I have some y values that are repeating. So 2 and -2 give me the same thing. -1 and positive 1 give me the same thing. So when you're doing absolute value, it should repeat. So let's see what this looks like. So now I'm matching up my ordered pairs here. My coordinates, -2, 5 would be an ordered pair. -1, 4. 0, 3. 1, 4. And -2, 5. So we're going to graph those points. So -2, 5 is left 2 and up 5. -1, 4 is left 1 and up 4. 0, 3 is just up 3. 1, 4 is right 1 and up 4. And, whoops, this is positive 2, not -2. Sorry. Let's make sure you see that here. And then 2, 5 is right 2 and up 5. So if you notice, this does not form a line, but instead it is going to form a V. So this is the key. When you see absolute value, your graph should look like a V, and it can either be going up or it can be going down. So you're going to take your ruler, and your V is going to have a point, and at that point your line is going to go, whoops, didn't get my line tool here. Your line is going to go forever in one direction, this way, and then also this way. Notice it doesn't continue past that point where the V meets. And this is what the graph of an absolute value is going to look like. Last one we're going to look at, notice this time you have an exponent of 2. So this is going to be different. It's not going to be a line. There's no absolute value, so it's not going to be a V. So we're going to see what this one is going to look like. So again, we're going to set up our table. We're going to have our x, our function, which is f of x equals 2x squared minus 5. And then our output, in this case, is labeled as f of x, which is the same thing as y. And then we're going to plug in -2, -1, 0, 1, and 2. Okay, we're going to start with -2. Now remember, when you are plugging in values, you need to plug it in parentheses. So I'm just going to write these down here, and then you can have your calculators ready. And all you're going to do on your calculators is just change the number that you are plugging in, or your input number. Okay? And if you do not, on your calculator, use parentheses, you are not going to get out the same or the correct answer. You have to make sure you're plugging it in parentheses. So, order of operations would tell us To do the exponents first, which would give us a positive 4, then we're going to multiply. 2 times 4 is 8, and then 8 minus 5 gives us a 3. Okay, now we're going to plug in negative 1. Exponents first. When you take a negative times a negative, it's always a positive, so that's a positive 1. 2 times 1 is 2, and then 2 minus 5 is negative 3. And I'm doing this by hand, but you could just plug this in on your calculator using your parentheses, plug it in, and it'll spit out the output for you. If you don't use parentheses, your answers are not going to match mine. 0 squared is 0. 2 times 0 is 0. 0 minus 5 is negative 5. Now we're going to plug in positive 1. 1 squared is 1. 2 times 1 is 2. 2 minus 5, negative 3. Notice we have a repeat here. Plugging in positive 2. 2 squared is 4. 2 times 4 is 8. 8 minus 5 is 3. Again, another repeat here. So when we have squared, again, we're going to have a repeat. So now we're going to graph our points. So once again, I'm checking my ordered pairs. So I have the point negative 2, 3, negative 1, negative 3, 0, negative 5, 1, negative 3, and 2, 3. So here are my points. So now we're going to graph them. So negative 2, 3 is left 2 and up 3. Negative 1, negative 3 is left 1 and down 3. 0, negative 5 just stays on the axis, and I'm going to go down 5. 1, negative 3 is right 1, down 3. And then 2, 3 is right 2 and up 3. Now, by looking at the points, it sort of looks like a V, but the thing that you need to memorize is that when you have an exponent of 2, this is going to form what we call a parabola, which is a U shape. And your U can open up or down. So when you have a quadratic function, which means it has an exponent of 2, you're going to be drawing a U. So you want to make sure this time you're not going to use a ruler. Make sure you are curving. This goes on forever. And you want to curve this down here because a parabola should be curved. Make sure you're not making straight lines. Make sure that it is curved. And that concludes your 5.3.